Okay, so for today in our video, I'm just going to show you what we started with. I had the kids start with just a normal factoring problem. And my steps are always make the parentheses. Then always start with x's here and make sure it works. Because like if there had been a 2 here, do you get x and x wouldn't have worked then? Like if there had been a 2 in front, x times x would have made just x squared. That wouldn't have worked. But you check and see, does x and x work? Because it usually does. X times x makes x squared. Cool. Then I always look and see, is there a negative in the problem? Yes, so you put a negative here. Then I'd like to revise what I said about this number. I said before that if the last number's negative, that there would only be one negative. And that's true. I wasn't wrong. But I think there's a better way to say it. If the last number is negative, it'll be a plus and a minus. Instead of saying there's only one negative, then I think it's better to say if the last number is negative, it'll be a plus and a minus. Is the last number negative? No. So it's not a plus and a minus. What does that tell you? Must be a minus and a minus. And why would that be? Because whatever numbers I put here and here, a negative times a negative will make a positive. So my new statement that I think is better than my old thing is that if the last number's negative, it'll be a plus and a minus. Okay? Now in this case, the last number isn't negative, so it must not be a plus and a minus. It must be a minus and minus. All right, so now last thing is what multiplies to 3? And I made it really easy because 3 only has one choice. It's got to be 3 and a 1. And raise your hand if you had that one right. Okay, cool. Now, you want to see what one step up from that is? Like, there's levels of factoring. The next step up is where it's like 2x squared. Everybody write this one, please. Minus 6x plus 6. Now what's different about this that makes it a little harder? Somebody already knows, I know it. Lindholm, I think you know. Yes! What is the greatest common factor? 2. So you take that out first. That will be one of the things that separates the A's from the B's is do you notice that they're all even? Or that they all have a 3 in them, for example. In this case, they're all even. And do you know that means you divide each of them by 2? You don't actually have to, but it's so nice because it tells you what goes first, which is x squared, what goes second, which is minus 3x, and what goes third, which is plus 3. And then, if you notice, I sneakily just made this the same as the last problem. X and x. There's a minus in the problem, so there has to be a minus here. If the last number is negative, there's a plus and a minus. If the last number isn't negative, oh, it's a minus and a minus. And then it's a 3 and a 1, and there we go. Now, one of the next things that kids do wrong is if I set it equal to 0, everybody please write equals 0 after it. If I set it equal to 0, focus, if I set this equal to 0, then I want to get the answers, and tons of kids think that that 2 changes the answers, and it doesn't. The answers are still just x equals 3 for this one, because it's the opposite of what's inside, or another way to say it is because you put a 3 there, it'll make it equal 0. See, you want it to equal 0. And the other answer is x equals 1. Do you get that 2 doesn't change anything? See, tons of kids think that you got to like take these answers and divide it by 2 or something. No, don't do that. The 2 in the front doesn't change these answers. Okay. Now that we've gotten through the common misconceptions, here's the thing that, again, tons of kids will be like, I'm stumped. I don't know how to do this kind. It's because they're not looking for the GCF. Please factor out the GCF on the pink one. We will be done fairly quickly today, so if you can just stay with me, do a few practice problems here with me. Really stay locked in and focused. This will get over with quick. Did you realize there was a 3 in both of them? If you didn't catch that, you got to get good at that. If there's a 3 here, then you go, is there a 3 buried in the 18? Yes, there is. 3 times 6 is 18. And I'm going to have extras of those little papers. You don't have to even take it out. It's up to you. I get some of you are going to use it a lot, and others of you are just never going to use it because you're good at going that like 6 times 3 is 18. Okay, but I have extras up on my desk here. If you need a multiplication chart, just subtly, just like you subtly walk up and grab my chargers. You don't have to, you know, make a contract with me or anything to take a charger. Just take the charger, or just take the take a pencil, or just take the multiplication chart too. So there's a 3 in both of them, but there's also an x. 3x, x minus, well, I'm not sure what to put there. Well, then divide it by 3x. It'll tell you what to put there. See, the 18 divided by 3 is 6. And the x divided by x cancels, so it's just 6. There we go. Now, I just told you last time that when there was a 3 out, or a 2 or a 3 out in front, that if I set it equal to 0, that didn't matter. This kind, it matters. Because there's 2 answers. One of them is x equals 6. The other one is for this. Somebody knows it. Yes?
You have to, for the one on the outside, it's, since you want to negate it, it has to be 0.
It has to be 0. Very good. Now, if you're like, but you just said a second ago that doesn't matter. No, it was just a 2 last time. This time it's a 2x. Do you get we need 2 answers for these things? If you ever find yourself just giving one answer, I'd be double checking myself. Because like, what? If this had just been a 3, it wouldn't have mattered. But if it's a 3x, you can make that equal 0. The point of this is 6 makes this part 0, and 0 would make that part 0. All right. I'd like to do one more like that because I feel like it's really critical. Everybody write this one. 5x squared minus 25x. And I'm going to say equals 0. So factor it and give the solutions. By the way, if you're the type of person who likes to know when the next test is coming up, I looked. You have to learn a bunch of stuff first, but the next test doesn't come up till next week, mid to end of week, kind of up to me right now, leaning towards Wednesday of next week, which is like a week. So you got time to learn this stuff. Did you realize that 5x came out? Why 5x? Because they both have a 5. And that makes it a greatest common factor of the numbers. And they both have an x. That's why. And then I'm dividing both of them by 5x. And that'll tell me what goes inside the parentheses. Of course, a negative goes in there. And the only thing left here is an x. Only thing left here is a 5. And then, like I said before, you got to know whether this thing on the outside matters or not. It does, because we'd only have one answer otherwise. And how do you make this part 0? If x equals 0. See, I put a 0 there. The whole thing will equal 0. Because 0 times anything would be 0. If I put in a 5, this part would be 0. And then the whole thing would be 0. Okay. So, now we're caught up. Now this kind. Do you remember the pattern for these? Didn't you say always to start with an x? I did. But I did say that you should check to see if it works. Is x times x going to make 36x squared? No, but it's going to make x squared. So, Marshall, what do you think we should put there? 4 and 9 would make 36, but there's an easier way. 6 and 6. Now, Now, always when you're doing this kind of problem, this is the kind where you're just figuring out the pattern. You use square roots. See, square root of 36, 6. Square root of 100, 10. So I'm going to use 10s at the end. And of course, I have a rule for you. Is there a minus in the problem? Yeah. So there's a minus here. Then, if the last number's negative, use a plus and a minus. And then last, I said we were going to use square roots. Square root of 100 is 10, 10, 10. Now, I know some of you realized, put Mr. Server, they were both even. And so you could have factored out a 2 at the beginning. Did anybody catch that? Oh, nobody even caught it. It's okay. But they were both even. You see they're both even numbers, and so therefore 2 did go into them. But watch how I'm going to fix that. Always look at your answer and go, could I factor it any more? Because factoring is good, but factoring it all the way is the key. And do you get that the 6 and the 10 have a 2 in them, don't they? So you can factor out this 2. 2 comes out, and then again, I got a system that'll work if you always do it. Divide by 2, divide by 2, and this gives me 3x minus 5. And same thing here. There's a 2 in both of them. 2 goes there. And divide by 2, divide by 2. If you want to know what goes in there, 3x plus 5. Now that I would have probably taken on the test as a final answer. But do you get a kid that put the 2 and the 2 together and made it 4 in the front? It would have been even better. Because this 2 times this 2 makes 4. And that tells you that the GCF was 4. And if in my ideal world, you would have noticed that there was a 4 in both of them. I totally get you probably didn't notice. I didn't even notice that there was a 4 in both of them, but there was. Because 9 times 4 is 36. And 4 times 25 is 100. So see how there's a 4 in both of them? But even if you don't notice it, it's okay, as long as at the end you realize, wait a minute, they're both even. I can factor out the 2. These were both even. So I factored out another 2. And this one's got a plus, so it was plus. And then I put the two 2's together. Now I think I could give you credit for this one, but I for sure would love to see that one. All right, that was pretty difficult. Relatively speaking, this next one is easy. 2 sets of parentheses. The only thing that makes it hard is not many people are running around going, I know what goes into 60. So start with things that are easy, like, well, I know 2, it's even, right? Or 10 goes into it because it ends in a 0. So again, don't just sit there with this. Go, well, I know it's got to be an x, got to be an x. Amina, do you know what sign has to go here? Yes, because the problem has a negative in it. That one's negative. And then I made up a new saying before you got here that said, if the last number is negative, it's got to be a plus and a minus. You got to have one of each. Okay? So now the only thing left is finding things that multiply to 60, but also give you 4. Honestly, I don't have a better way for you than just listing everything and trying everything as you come to them. Like, I'm going to try 2 and 30. And do you get pretty quick, you can tell that's not going to make 4x, a 30 and a 2. Like, that can't be it. So then I would make a list of what I tried. 2 times 30, I tried it and it didn't work. How about 6 and 10? 6 times 10 makes 60. Ooh, I bet 6 and 10 is going to work because I think to myself, can a 10 and a 6 make a 4? I bet it works. Who's got it? So who had it before me? Nice. Dylan, what do you say? We're x minus what and x plus what?
X minus 10, x plus 6.
X minus 10, x plus 6. And I can check him quick by going negative 10x for these two. 6 times x is 6x for those two. And when I put those together, it makes negative 4x. If it had made the opposite of what you wanted, you would have changed the signs around. Not the numbers, the signs. If you ever get the opposite, change the signs. And I know some of you still don't get why. It's because of the thing I'm teaching you today. That the signs have to switch, not the numbers. I know on this problem you could have switched the numbers around and it would have worked. But when you get the opposite of what you want, switch the signs. All right. Since GCF is going to be the biggest deal, would you just factor out the GCF on all of these? Come on, stay with me. Yeah, sugar crash, probably. Stay with me. Try this. Try the blue page. Just figure out what goes into them. It's finding the GCF and then dividing by it. Saying what went into 25 and 100? 25. And if you're like, well, I don't know what to put on the inside, then do the little divide by 25 thing. And I get x squared plus 100 divided by 25 is 4. Now, be careful. X squared plus 4 would not factor, at least not with real numbers. But I was just explaining to a colleague that I think it's worth teaching you this right now. And I understand that not everybody's going to understand this. But this can factor with imaginary numbers. See, that plus is supposed to be a minus for this to be able to factor. So if you want it to factor kind of like those other ones, like x squared minus 4, that would have been x plus 2 and x minus 2. You get how that one works? Well, if it's a plus, then you can do plus and minus 2, but that wouldn't normally work. Why? Because it would make negative 4. So you have to add in something called I, which I don't know if you even know what it is yet. But if you want to do that, I would have taken your answer because it's factored using imaginary numbers. I know, that might be a bridge too far for some of you. I would have accepted just leaving this alone. The reason it works, by the way, if you're one of those top students who's like, yeah, explain that to me, Mr. Server. Because 2i times 2i is 4i squared, and I squared is equal to negative 1. So this comes out negative because there's a negative in the problem, and I squared is a negative 1. So guess what negative 4 times the negative 1 makes? Positive 4. So I know that might be too far, but if you want to factor things with a plus, I'll be good with that as long as you put in an I here and here. On our next chapter, that's something that everybody should be able to do. I'm just teaching it to you a chapter early if you can handle it.
A question?
Yes?
What value is I unsquared?
I is equal to the square root of negative 1. So the mathematician who figured this out said, you know, we could actually solve these problems if we made up an imaginary number, which I know sounds like, yeah, come on, you're just making crap up. But square root of negative 1, if you type it in a calculator, it'll say it doesn't work. It doesn't know how to do it. Okay? But they made up this I for it, and then that I actually now, we can use it in the real world to make equations for electricity. Where this I equation, the equation that has this thing that the guy made up that doesn't even make any sense, kind of, is allowing electrical engineering equations to work in the real world about electricity. So, bottom line, it's in a made-up thing that can be used in the real world. All right, that was probably too much for some of you. On this one, I hope you just realized that they all had a 10 in them. 10 came out. X squared minus 10x plus 4. And it probably factors again, but I told you, just factor out the GCF for today. For the test, you would definitely want to factor it further if you could. Actually, in this case, you can't. So, yay, we're done.
Yeah.
Okay, on this one, it seems like 7 goes into everything at first, but then no. There's no GCF on this one. The only thing you could factor out would be a 1. And that really wouldn't help anything to put a 1 in front of it. Because you're dividing everything by 1, it's just like you got the same problem back again with a 1 in front, and that doesn't help. All right. So,
What do you do if you get that?
oh, then the answer is just that you can't factor it.
You just write that out.
It's kind of like if I asked you to factor 28, you'd be like 2 times 14, and that's good. And if I asked you to factor 7, then we'd be like, well, it doesn't really factor.
Yeah. Okay.
So that's called a prime number.
So if we had one like that on the test, we just,
That's a good question. I don't think we're going to do this, but if we had one that won't factor, like I'll give you one that won't factor. That won't factor. And if we say to factor it, then you'd say prime. Prime means it can't be factored. Other than cheating and using 1. Technically, the definition of prime number, it is 2 factors, 7 and 1. It has 2 factors, itself and the number 1. By that definition, technically, 1 is not prime. A lot of people think 1 is a prime number. It's not, because it only has 1 factor. Prime numbers have to have 2 factors, 1 and itself. And I know it's kind of like a catch-22. I've even seen it in a movie where they made that mistake and they were listing the prime numbers and they put 1 in the list. Nope. You can look it up. 1 is not a prime number. Prime numbers have to have 2 factors. Okay, get to this page. This would be like an R4. Nope, R3. R3s are the hard ones where you get 5% added on if you can figure them out. The R4 is where like we wouldn't even expect you to be able to do it. But this one, you could figure it out. So first thing I'd be thinking is, does 2 go into either one of them? 2 goes into, no, 2 doesn't go into either one of them. The next logical easy thing is, does 3 go into them? Yes. So you factor out the 3. Divide by 3, divide by 3, and your calculator can totally be used on the test, right? So 27 divided by 3 would be 9. And 75 divided by 3, somebody can do it in their head. 25, very good. So factoring out that GCF is the thing. That's why it was the first slide of the chapter was that meme. You always had to factor out the GCF first. Okay, so there it is. And now, just so you know, this one could also have been factored to a 3x and a 3x, because that makes 9x squared. There's a minus in the problem, so there's a minus here. The last number's negative, so it needs to be a plus and a minus. And 25, you use the square root, and you go 5 and 5, and that's actually what the final answer would have been. Just do it step by step. First step, make parentheses. Next step, figure out what's in the first part. 3x and 3x makes 9x squared. Then figure out what the signs are. Has to be a minus. Then it has to be a plus and a minus. And then you're only left with one thing, which is what number is here. You can use logic to get all the way to the last number. And that one, in this case, it's just 5. All right, moving on to this page. Go to the 4th page. Honestly, I feel like you've got this now, and then like literally, we are almost done. Like, I don't really have much more to teach you, except you gotta factor the GCF out first. Hugh, do you see what they all have in them?
4.
Yep. Do you know when a kid's like, well, yeah, but I don't know what to do after that? Do you know what to do after that?
You divide.
Yes. Divide them all by,
4.
yeah. And that'll tell me x squared. What's 40 divided by 4? 10. 44 divided by 4? 11. Nice. And then you should ask yourself, can I factor it again? And in this case, you can. Someday when you're older, you'll look back and realize, I was killing myself without sugar. That's why I couldn't concentrate in math class. I know, you don't think it's true. It's true. Talk to amazing athletes, and they'll tell you, I can see a big difference. Not just in your athletics, but also in your brain. All right, start with x and x, and then I have a minus here, and that makes a minus here. And then if the last number is negative, it's got to be a plus and a minus. And that leaves me with only one thing. What makes an 11? 11 times 1, and then the only thing you could do wrong here is to put it in backwards. This one's, the positive number is the bigger one, so I make the bigger one positive. 11 and 1. There we go. All right. We've made it, boys and girls. Last problem of the day. And then we're starting homework. You got time with your cell phone back again, and life is good. Focus. One last problem. Do you think there might be a GCF? Yes, of course. Factor it out. Factor it again. I know. You have a different life right now. Still do math problems. I can write it too. It's 5x squared. 5x squared minus 40x plus 80. Sadie, what did you factor out of everything? 5. What did you do? Or actually, you might not have even done it, but what could you do to figure out what to put in here? Divide everything by 5. That's what you do to figure out what goes in here. Okay, Sadie, what do you have for the first part? Yup. That's the first part. The second part is? And then the last part. How did you get 80 divided by 5? I'm not saying you're wrong, I'm just asking you. Like, really, how did you get it? Did you like just know that? Or did you divide it on a calculator, or what'd you do? Awesome, because that's what you'll have to do on the test. Because nobody in here probably knew what 80 divided by 5 is. Oh, maybe you can. Maybe some of you can.
Well, obviously it just 40 doubles.
All right. All right. So what do you think it is, Nico? 16? All right. Now, do you suspect, Lindholm, that this can be factored further? Yeah, I think so too. So then I would try at least. Now, sometimes you can't, but this time you can. So, Nico, how do I start it for sure? Nico, this time.
X minus on both.
Wait a minute, minus and a minus?
Yeah.
Talk me through how you knew that, because some kids honestly don't know that. Yep. And when that's negative, you use a plus and a minus. But when it's positive, you don't. Okay. All right. Lindholm, finish it off. How do you make a 16? 4 and 4, and that will work because that's negative 4x and that's negative 4x. Total's negative 8x. There's your answer. It's factored. On the high-level math questions at the end of the test, they're going to make you say, and x equals this and x equals that. Well, it would be x equals 4 and x equals 4. And I warned you, if you ever got the same number, just be sure that you're not screwing it up. But we're not screwing it up. It's just 4. And yes, you could write 4 twice, but you don't have to. If you're like, but Mr. Server, there's usually 2 x-intercepts. There usually is. But if the parabola does that, then there's only 1 x-intercept, and we call it a double. See? A double. You'll learn later in this class, that's called a double root. And last but not least, for the kids that can handle it, you all should know how to do this. That should be easy pants. X plus 5, X minus 5. But if I make a plus here, I told my A and B students, you could factor this with imaginaries. Try it. I'm teaching you something one chapter early. You'll need it for next chapter. But I think now is the perfect time to teach it because it's just X and X. And normally it'd be X plus and minus because that would normally be minus. And it'd be a 5 and a 5. But that doesn't work unless you put in an I. I know. It's weird. Did anybody get that before I said it? All right. 6 of you benefited from that. Do you have to do that? No, you don't. Because it's not real.
But you're able to use it.
But you're able to use it, and on the test, that on next chapter's test, that will help you, but not on this chapter. Before this chapter, you don't have to know that yet. I just thought I'd teach it to you early. All right, now your homework. It is a worksheet. I have it on paper. Now, if you insist on doing it, grab it, start it around. If you insist on doing it, just pass it around that half and I'll go from the other side. This half. If you insist on doing this on your iPad, I will allow you to, but I'd really rather just collect them all on paper.
That's what we do.
There's 2 sides. I'll tell you which side you're actually doing once you have it. So please clear off your iPads at this time and just use the paper.
My friend, I like my backpack and my
Those of you that have it and you want to start with the problem that has an X in it. The problem that has a C in it, save that. I think that's going to be an assignment later. Start with the problem that has an X.
My friend stole my pen and I put it behind my phone and I lost it.
Okay. I got it. So start on the side that has an X. If your problem has a C in it, you're on the wrong side. Now please put your iPads away. All right. Number 1. Osberg, would you read me number 1, please?
X squared minus 2x.
X squared minus 2x. Keep going.
Minus 8.
Minus 8. All right. I always know to start this way. Alex Wilhelm, what's always next?
The 2x.
Yep. Then we ask a sign question. More in the front row. What's the sign that goes here? Minus. And then the new saying, Caden, this last number is negative. What does that mean?
Means negative positive.
Yup.
Yeah.
There's 1 negative and 1 positive. Zane, you got to find 2 numbers that multiply to 8. I know there's lots of combos. 1 times 8, 2 times 4, and, well, 4 times 2. I guess it's kind of similar but different. Zane, what do you think I should put? X minus what and X plus what? And if you're not sure, here's how you check. Negative 2x, 4x. Does that make negative 2x? Look close, Zane. Does that make negative 2x? See, look. These 2 numbers, they make positive 2x. Ah, so then we switch this to a plus and this to a minus. Trust me, for the problems on the test, don't switch the numbers, switch the signs. You'll see why. And then that's your first answer. You don't have to do both sides of the worksheet. You only do the side that has the X in it. And I'm going to give you a few freebies to skip. You may skip number 13 and number 14. But that's it.
Is number 2 an error?
13 and 14 are kind of weird, so skip them. Number 2. Nope, because the 5 times 3 makes a 15 and it will work.
No, like, is it supposed to be an x squared and a number two?
Oh, it's supposed to be squared, you are correct. Number 2 should say x squared. I didn't even see it. This here should be at x squared. On number 2, that should say x squared. So are you saying that it's, okay, let me look on my side. I gotta use a hub pass. You gotta show it to me too.
Yeah, this is 5G,
Just walk back this way when you get it made. Cause it doesn't like send me an email to show me that, so
Oh, right.
some kids think that they made a hub pass and they don't actually make it, so I make everybody show.
Oh, you're right.
All right, and you only have to do that one side of the worksheet, and you're skipping 13 and 14. And that's all I got for the video for today.